Our motto, determine equivalent resistance between A and B. So how can we determine? First of all, check series parallel. This R and this R are series. This R and this R are series. Very easy way. So you can say that is 2R, and this one is also written as 2R. Clear? After that, again recheck which one look like in easy way series and parallel. No one look like in easy way series and parallel. Okay. Now next target, how can you resolve it? This is the wire, note this wire like this one, no resistance between this terminal and this terminal. Okay, this is the ideal wire. So this point and this point represent same potential. So if this point is C and this point is also C, clear? That is A, this is also A. Now this point is D. Okay, after that redraw the circuit. Now, so first of all make again, that is A, and last point is B, and this point is C, and this point is D. Clear? A, B, C, D. So A equivalent, our motto, determine equivalent between A and B. So this A and this B is always represent last terminal. Okay. Now first of all make resistance A to C 2R. Now another way, A to C 2R. Both are parallel. Both are connected in parallel. So 2R, combination of 2R, if both resistance 2R and 2R are parallel. So what about equivalent resistance between 2R and 2R? That is R. If both resistance 2R, that is 2R, and this one is also 2R connected in parallel, then that is A and that is C. So R of AC, that is R, simple R. Okay, so you can make, that is simply R. Simply make R like this one, that is R. Clear or not? After that, what about C and D? C and D, that is R and that is R. Okay, both are parallel. C and D, C and D, C and D, C and D, that is R by 2. Okay, R and R. So if R, this is also R, then whole combination, that is R by 2. So written R by 2. So this resistance and this resistance are finished already. Make it make here. Okay, now next one, A to D. A to D is R. A to D, simply R. So make R. Okay, now next one, C to B 2R, C to B 2R, 2R and 2R, combination of 2R and 2R, that is both, that is R. So C to B, that is R. Now last one, D to B. D to B is R. D to B is R. So that is R. Okay. Now look like Wheatstone bridge. If you see here, look like Wheatstone bridge. R. You check symmetry. This ratio, R is to R, 1 is to 1, 1 is to 1. Or you can, if both are 1, if 1 is to 1, 1 is to 1, then that point are same potential, or you can check with the help of Wheatstone bridge, both are same potential. Okay, so if both are same potential, then that is R and that is R, and this one is R and this one is R. Okay, and that point A and that point B. So R of AB is, that is 2R and that is 2R. So finally R. Equivalent resistance is R. Make it. Clear? Clear or not? Very simple. That point same potential. So first of all make. Okay, consider same potential. This 2R, combination of this 2R and this 2R, because of A into C, this potential also A into C, that is R by 2, sorry 2R R. Okay, now C to B that is 2R and that is 2R parallel, so combination R. A to D that is R simply. D to B that is R, and C to D and C to D that is both are parallel, so R by 2, and look like Wishton bridge, and final R resultant is R. Make it.